Hello everyone, my name is Shanti Duggad. In this video, I am going to explain the concept of standard deviation and coefficient of variation. The video will cover basically the meaning and statistical formula for calculating the standard deviation and how we can use the standard deviation in finance. I will explain with some examples and then I will move to coefficient of variation. What is the difference between standard deviation and coefficient of variation? Standard deviation. Standard deviation is the most widely risk, which defines the magnitude of deviations between the values contained in the dataset with respect to its mean value. So, in other words, we can say that standard deviation denotes how each value is differing or closer to its mean. So a low standard deviation means that the values tend to be closer to the mean, or a higher standard deviation means that the values are spread out over a wider range from the mean. So we can find the standard deviation using the statistical formula which says like this: sigma equals to under root of summation x minus x bar squared divided by n minus 1. N minus 1 when we use the sample, and we divide it by n when we use the population. So where xi is equal to one value in the data set, x bar is the arithmetic mean of the values in the data set, and n is the number of observations or values in the data set. We can also calculate the standard deviation by taking square root of variance, because variance is the sum of x minus x bar squared divided by n. So we don't do the under root of these values in variance, whereas in standard deviation we do the under root of this whole thing. How do we use standard deviation in finance? So in finance, the standard deviation is mostly used to calculate or to measure the volatility of the rate of return on an investment. It can help investors to quantify how risky is the investment and what is the variability of the rate of return on that investment, and they can compare it with their minimum required return on the investment. So it helps them basically in the decision making process. If in finance we can modify the statistical formula using the probability distribution of expected return outcome as under. So we saw here R minus R bar. Here in finance we use R because that denotes the return instead of X. So RI is the return of the ith outcome minus R bar is the average return. So the difference between the two values and squared of that, and for each value that is a sum taken, and each value is multiplied by the respective probability distribution, and then the sum is taken, and if we take the square root of the whole thing we get the standard deviation. So let's understand this with a practical example. So in finance we can say the greater the standard deviation of returns, the greater is the variability or dispersion of the returns from the mean. That means higher is the risk of that asset or that investment. So we will see an example here. If there is an asset X, suppose the annual return expected, optimistic scenario is 20%, realistic scenario is 15%, and pessimistic scenario is 13%. So there are three values in this data set. So average of these three values comes to 16%. 20 plus 15 plus 13 divided by 3. So average comes to 16, which is R bar. So when we take the difference between 20 and 16, it is 4. The difference between 15 and 16 is -1, and difference between 13 and 16 is -3, which is R minus R bar. The next step is to take the square of this. So 4 square is 16, -1 square is +1, and -3 square is +9. So the next step, we multiply this R minus R square with the respective probability. So assume the probability of optimistic likelihood is 30%, probability of realistic outlook is 50%, and probability of pessimistic outlook is, let's say, 20%. So we multiply R minus R by R bar square with the respective probability. So 16 times 0.3, that is comes to 4.8. 1 times 0.5, that becomes 0.5, and 9 times 0.2 becomes 1.8. So total R minus R bar square times the respective probability comes to 7.1, and when we take the under root of this 7.1, we get the sigma Rx equals to 2.6646. It means that the variability, average standard deviation of getting return from X is 2.6646. Similarly, if we do an example with asset Y, let's say asset Y has optimistic return of 24%, realistic return of 18%, and pessimistic return of 15%. So the average of these three data values in this set is 19%. So 19% becomes the R bar, that is the expected return. And when we take the variation between the individual value with the expected value, it is +5 here, -1 here, and -4 here. And we take the square of that. So +5 square becomes 25, -1 square is 1, and -4 square is 16. And we multiply with the respective probability. So assume probability of this is also same as asset X, 30%, 50%, and 20%. So we get 7.5 for optimistic outcome, 0.5 for realistic outcome, and 3.2 for pessimistic outcome. So total of R minus R bar squared times probability becomes 11.2. And if we take under root of 11.2, it gives us the value of standard deviation for the return of asset Y, which is 3.3466. So we can say in simple terms that asset Y is more riskier than asset X because the standard deviation of asset Y is higher than standard deviation of asset X returns. Let's understand this with one more example. Let's say here there are 5 years, stock X and stock Y. Stock X has generated return in this manner: 3%, 4%, 5%, 6%, 7%. So we can see here it is gradually increasing and the mean of the return is 5%. Stock Y has given a return of 1% in year 1, 12% in year 2, 2% in year 3, 8% in year 4, and 2% in year 5. So here also the average or mean is same as 5%. However, when we calculate the standard deviation of asset X, it is 1.41%, and for stock Y it is 4.29%. Now if we plot these returns in a graph, we can see here the green line is for stock X. So this is very steady line increasing, no fluctuation at all from 3% to 7%. Whereas a red line which represents the return generated by stock Y year on year basis, it is quite fluctuating. Sometimes it goes as high as 12% and some year it goes as low as 1% or 2%. But the average of both the stocks return is same as 5%. Now, obviously, as an investor, which stock you will prefer from the risk perspective? Stock X. Why? Because stock X has the lower standard deviation compared to stock Y. So, in order for an investor to invest in stock Y, they would require some extra element of return to motivate them to invest in stock Y. So, this is how the standard deviation concept is used in finance and investment. Now, let's see the concept of coefficient of variation. We saw standard deviation is an absolute measure. It does not correlate the deviation relative to the mean of the value of the data set. So when these two data sets are totally different sizes or different units altogether, for example, if you want to compare the weights of mice and weight of elephants, so they, though they are both the animals, but their sizes are totally different, so you cannot compare the standard deviation of mice with the standard deviation of elephant. Similarly, if you want to compare the two data set, one is having weight, another is having height, so these are two different units of measurement, so it is irrelevant to compare the standard deviation of a weight data set vis-a-vis the standard deviation of height data set. So in such scenario, we cannot use standard deviation as a comparable measure of risk between two data sets. So what we use is the coefficient of variation, which is basically the standard deviation of observations divided by the mean of that particular data set, and it is always represented as a percentage. So we have to multiply this fraction by 100. So we can say coefficient of variation is a measure of risk per unit of expected value. It converts the standard deviation relative to the expected return, which enables the comparison of risk associated with the assets having different size of expected values, different size or different units of measurement. So let's see the formula here. CV, which is coefficient of variation, equals to sigma r divided by r bar, where sigma r is your standard deviation of return, as we call it in finance terminology, and r bar is the expected rate of return or the mean of various returns. So if we put those values in this formula, for asset X, we got standard deviation of 2.6646 in the previous example, and expected return R bar was 16%. So the CV, coefficient of variation, is this divided by this becomes 16.65%. For asset Y, standard deviation was 3.3466 and the R bar average return was 19%. So the CV value comes to 17.61%. So we can say that return. Thank you. I have created some more videos on many financial management topics and statistical concepts. So if you want to refer to those, you may go to my channel. And if you like this video, you can share with your friends. And if you need any explanations or some interactive sessions to understand the statistical and financial management topics in more details, you may contact me here at dugat.shanti68 at gmail.com. Thank you.